verify just to make sure. And yes, we are live. Nobody yet that joined, but let's have a look. Later people will join, I'm sure of that. So, to recap what I did yesterday, or what we did yesterday, we created a ring that consists of two cylinders, one subtracted from the other, and the whole thing with a height of 10 millimeters. That's this part. Then we defined the very technically named NUPSI, which are those extrusions here. And we also subtracted those extrusions, rotated 180 degrees on the y-axis and rotated 60 degrees on the z-axis, such that two rings can combine together like that, more or less. So those are simply connectors for the idea that we had, me together with Dennis or Wurstbude, on making something to have for various hacker events, to make lighting a bit more interesting. So yesterday I outlined a very basic idea of the whole ordeal that looks something like that, which basically consists of a heptagon extruded and rotated, and on top of that another heptagon which is also extruded and rotated. Yeah, so now what people can practically print is something in the length of 250 millimeters, height in that part, and I would say a radius of around 120 to 150 millimeters. That way, even most small 3D printers, not the tiny ones, but most small 3D printers can print it, and even the tiny ones, those people could scale it down vertically, and then it wouldn't be as big, but it still would work. On that part, I also have some scaled vertically. So yesterday I rambled about a bit in code. This is what rambled together code looks like. It's very ugly, it's very rudimentary, but it's more or less okay. To just illustrate the concept. So what we have here is actually two parts, and you see here that's the terminator between the two, the surface that separates them, as you might see that way, which is, if you ask me, is okay because this curvature will not be continuous, and I don't think it also, and I also don't think it actually needs to be continuous for the very simple fact that the effect is not. I don't think the effect will be impeded by the whole idea. So first of all, we need to define, what I want to do is to start with a defined rotation towards, so we start with a defined orientation of the heptagon. I would go for 0 degrees, just for simplicity's sake. And I also want to end with the same rotation, such that you can click them together and they are seamless, more or less. Yeah. So, in order to achieve that, we first of all will need to define a module that actually has some input parameters. One would be rotation, which I would define as 0. And let me. So, okay, yeah. So the rotation, which I would initially define as 0. And further on, I would proceed. Let's start with that. So, first of all, what I want to have is let's define it that way so that we don't always have to think about what we are doing there. Let me first define the basic dimension, the basic thing called Heptagon. And here we have the first additional variable that we need, and that would be actually be the circle here, which again, this needs to be a module with no parameters, and here we would actually need the initial radius of the heptagon. So let's go. This is always the enclosing circle of the polygon that is defined here. This $fn defines the number of edges the geometric object does have. So okay, let's define the radius and define it, and let's say it's 120 initially, and let's use it here. Okay, we got that. What else do we need? This is the initial rotation again. Let's stick with that for now, actually. And let's go here and do a rotate, and rotate it 0, 0. We don't want to rotate it vertically. We just want to rotate it in this around the z-axis, so like that. And because it's supposed to have a heptagonal symmetry, let's put it that way. And let's put the rotation in here, and the heptagon here. Just to be sure, let's put the curly brackets around that part. Okay, so then about the height, I think I want to define the height. I want to have a homogenic height among the simple sections. So for now, I think I will stick with the 25 millimeters. How much in, and since the whole thing has to be like 100, let's say 250 millimeters, so we have 10 sections. This is perfectly fine for me. The twist. So what's going to be the final rotation? I think I want to have that also as a parameter, such that I can call this function and have it be that I can call this function multiple times and generate simply the starting conditions for the whole thing, and subsequently have and so this module is as stateless as it gets. So let's say the twist is 100. I don't know. Let's stick with 60 degrees. 60. I like 60 degrees. Either way, let's also make the height a variable, even if we don't set it. I'm not sure if that works. We will find out shortly. Here, let's do the twist again. Whoever got that reference, raise your hand. Oh, only 2 viewers. So, let's see. Okay, and the final scale. This one, I would like to have it also I would also like to have it as a variable. Let's stick with 1 for now. All right, so let's do I would go with the homogenic slice height, because right now, let's put that also as a variable in here. Slices, let's do 52. So let's go like that. Again, I'm not sure if that works at all, but we will see. Okay, so let's get rid of the second part. Let's just let's see. So what would we expect right now? It would be a rotation of 0. It would be a let me check something that I know it's free to check your mobile phone where you're on stream, but somebody's having issues, but I don't think it's on our end. So okay. So now we only need to call this part. Let's call this section, and let's see what goes horribly wrong. Okay, I forgot a semicolon. Everybody who has programmed before knows that pain. There we are. This looks actually nice. I like it. Although, you see what I did here? I want to have a diameter of 120. This looks much better. This looks really good. I like that. So, also what I need is an offset. Let's call it Z offset and make that 0 for now. Because if I want to stack them one on top of each other, I would need to have I would need to be able to define multiple. I will need to say, okay, the next one starts there, and the one after that starts there, and so on and so forth. So let's try this variable. First of all, I do have to translate the whole thing here. La la la. Yeah, of course that goes there. And we have to indent this whole thing. And we need to translate it by 0, 0. And of course the Z offset. Let's do that. This of course opens up the possibility that we could also define an X and a Y offset, maybe in the future, but I think this would complicate things further, and I don't want to go there right now. Later, if somebody wants to implement that, you are more than, be my guest. I do accept. Pull requests. So, okay, let's have a look here. So we have a section, and then we have a section. So we have it here. Oh, nice. Of course, the rotation is whatever, right? So we would need to define the rotation here. We start at 0 and we end up at 60 degrees, so I want to have it there. And of course, I need to do it that way. Yes, I need to do it that way. Why though? Why do I need to do that? So apparently the rotation is counterclockwise. The twist is counterclockwise. No, it's clockwise, and the rotation is always in the positive direction. And if you look at a clock, the positive direction is counterclockwise. So as you can see here, we start from the bottom and then we go clockwise, and positive direction is counterclockwise. So yeah, let's do that. This looks actually pretty good. I'm happy with that. So now I'm quite confident that this module works. I mean, it doesn't do anything spectacular, to be honest. So yeah, it would be a surprise if it didn't work. So yeah, let's go on. So, let me check something. All right. So yeah, so this does work. So for now, we need to generate. Let's start with the simple things. We need to generate. Let's assume we want to have the 250 millimeters, and we want to have, and each section has to be 250 and 25 millimeters, which is right now the case. Let's go like this, because 10 iterations produce 10 iterations of this thing produce 250 millimeters. Basic arithmetics, right now. So so for each I need to calculate an offset first of all. This is quite easy, to be honest, because here we can basically just say that my Z offset is I times 25. That means the ith element starts at 25 times I height, which is intuitive, I think. Then for each element, we need to have a random rotation. This is a tiny bit more complicated because the rotation of the one element depends on the rotation of the other. In my previous stream, I said, yeah, let's just have all the elements click on the symmetry on the rotational symmetry of the heptagon. That means that we would have let me calculate that. What is 360 divided by 7? Yeah, 51 degrees. This is nice and everything, but I think it removes the idea. It removes the randomness and it removes a lot from the aesthetics. So I thought about it and I think I don't want to do that. So I would need an array, something array-like, to store some rotations and have the one element. So I need to generate a rotation for each element, and then subsequently I need to generate a rotation and a twist for each element, and the next element would its rotation would be the rotation plus a twist. So the 0th element will always have a rotation of 0, and the last element, the 10th element, will also have a rotation of 0. Just to make the continuity there, so that we can click the elements together and have a continuous tube. Let's put it that way. So let's search for arrays in the manual. Again, the OpenScad user manual is something I highly recommend, and I don't do any fancy. I don't do anything that's not in there. I'm basically right now Googling also the manual. So basically you accompany me in learning, which is nice, I think. If you like that, I'm happy I can show you stuff. One feedback I got from my yesterday's streams is that I don't interact with the audience enough. If you want to, please feel free to chat, and we can do that. Okay, I have no idea what I'm doing here. Anyway, whatever. Okay, so I'm fighting with a Twitch thing. I'm new to that. Sorry for my rambling. Okay, so we do have mathematical functions and mathematical capabilities in OpenScad. As you have seen, we do have access to things like sine, cosine, and square root, and round, and whatever. So let's see if we also have arrays. So let's see. Okay. Okay, in OpenScad they're called vectors, and we can define them. I'm not sure if I can define them empty, but it should be possible. Okay, let's see. So we would have an array of size. We would have an array of size 10. We would have a vector of size 10. So let's go for it. Again, sorry for my rambling. I'm right now looking for what I'm doing here, for what I want to do in the manual. Okay, so basically I want to have a possibility to generate a random vector. Okay, so there is the function called rand_s. Okay. And apparently I also can get a random length vector. And okay, so let's see where this leads. So I want to have the rotation, the respective. You know what? Actually, the nth element only depends on the. Let's generate a twist. First, a twist vector. So let's call it twist and do it like that. I want the minimal twist value to be 0 and the maximum twist value to be around, it's only 25 millimeters. I think 60 is a bit too much. Let's go with 30. So it will have a random value between 0 and 30. And then how many numbers I need? I want 10. So this is the minimal value. This is the max value. This is how many values I want. And then I could define a seed, which would make the whole ordeal deterministic. So let's go. Let's use the seed 42 just to get less surprises. It can of course happen that this seed is a well-behaving one, and then and that with a another seed something goes bonkers. But let's stick with that for now. So okay, and I'm right now looking how to generate an array with multiple 0 entries. Of course, I could do it like that. I could say, okay, A equals 0, 0, 0, 0, 0, 0, 0, 0, whatever. Like that, but I don't want that. I don't want to, I don't want to define it like that. I wanted to have a very, I would like to have to be able, I would like to be able to make this a variable like that, like how many sections I want to have vertically. So also to be able to then derive the height from that. So maybe I want less elements, maybe I want more elements, maybe I want the elements to be higher. But for now, let's stick with 25 millimeters and 10 elements in there. You might ask, why do I do that? Why do I say, okay, I want 10 elements from the get-go? The thing is that having 10 or having 2 doesn't make much of a difference anyway. So I basically want to I want to go that way, because either way it's the same path I have to go through. Okay, let's have a look. Okay, so let's go that way. Okay. So we have the Z offset defined here. Okay, we wanted to have the random, the 0 vector So basically now I want to initialize the vector. Apparently OpenScad support list comprehensions. Let's have a look for that. Okay, we can do it that way. So we can go equals for I equals 0 to 9. No, I did that one wrong. We can just return 0, and this should return a vector for, this should actually return a initial condition. This should actually return an empty string for the whole, and this should return a vector with 10 zeros in it, according to the documentation at least. Let's go back to the manual and let's see if there is also a way to sum vectors. There are vector number operators defined in the manual. And okay, those apply to the whole vector. There's also matrix multiplication options, conditional operators, and whatnot. Okay. So let's see if there's a sum over I mean, either way I could actually add the I could always add the whole I could do it manually. So for each for each I for each element in here go here and add the subsequent and add all the preceding twists, and so I get the starting rotation for each element. So actually, you know what? I think I might do that. It's gonna be ugly as hell, but I think it's right now. I think it's the only way. Oh, thank you very much, Melmoth. That works. Oh yeah, I know that works. What I want to do is something along the lines of sum and then the vector, and I get the sum of all elements of the vector. Because I need to add, Melmoth the sheep said that if I simply add two vectors, so if I do vector 1 plus vector 2, then they are added. Also, you can multiply vectors with each other, or you can multiply vectors with a single number, and the whole vector will be scaled up. But this is not what I'm looking for here. I'm gonna try it, and maybe if there is a quicker way, please feel free to educate me. Again, I'm learning here too. So now I have an iterator. Let's stick with I, whatever. It's going to be destroyed after the loop anyway. So or rather, it's going to be initialized here anew. That's the safer bet. I would say that's the safer way that OpenScad works. That's the safer assumption to do about how OpenScad works. Let's say it that way. So now I do need to have I do need to select a sublist of OpenScad. No, that's not what I need. I think we have it here. So basically what I can do is for j equals from 0 to I, 0, not O, to I can do that. And let's go here. So basically I do iterate over the whole length here, and here I iterate. I would go from I would go and say boom 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 and go total rotation. Does the plus equal operator work in OpenScad? We will soon find out. So plus equal. Nope. Yeah, no, that okay. I don't find anything in that direction. And no, it doesn't look like that. So let's do it that way. Let's do it the old school way. Plus twists, and let's select the jth element. So basically what I do here is for each I do determine what the total I do determine what the sum of the rotations up to that point is, and return the total rotation. And let's remove these things and just do echo. And I want to see what the result of this whole ordeal is. I'm not sure at all if it works. Rotations. Honestly, I have no idea. Yeah, what went wrong here? Let's go to the console. It says syntax error. Okay, great. Oh boy. Thank you very much, Melmoth. Melmoth helps me here a lot. He says that there is no way to redefine the value of a variable. And okay, I did find he sent me a link to a snippet that from the OpenScad user manual. If you're on Twitch, you can see the chat. If you see the recording, probably you can't. I don't know. Which looks like that. Let's paste it here. And this is a recursive addition function, and what it basically does is add a vector from that. It adds I will read the documentation here. Create a simple recursive function that adds the values of a list of floats, the simple tail recursive structure makes it possible to internally handle the calculation as loop, preventing a stack overflow. So basically, yeah, this is the whole function, and if I see it right, you start. I do have to play around with that. So this somehow breaks. Boom, 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 boom. Okay, thanks a lot. Thanks a lot, Melmoth. The sheep. Output, add input. Okay. Okay. Let's see how that works. So twists I equals, let's go I equals 5, and let's return twists so that we can be sure that this makes sense. And for now, let's comment the whole block here. Okay, and let's go. It doesn't like that. Why though? Oh, yeah, of course. It needs more brackets. Resembles a bit of Lisp, to be honest. So this is the whole thing, and those 5 elements are supposed to be like 77, which is more or less right, because it's a bit less than 25, it's a bit more than 25. This is less than 25, and it sounds sane to me. So yes, thank you very much. This really helped a lot. So let's go back here, remove that, remove this monstrosity of a definition, and go like this. Add twists I equals I. If I hit my keyboard right, then things happen correctly. Why don't you want to work? Somehow in list comprehensions this doesn't work. Does it though? Let me check again. Does it though? I think there's a really nice way to find that out. Let's do it that way. And I think I need to do it that way. This part here. I don't know why it doesn't like the curly brackets, but let's make sure. I think that was the issue. I think now it should work also with curly brackets. Now we are debugging 2 things. Screw that. I want to see how this addition works. And yes, you are the I is where it starts, and I think what I need to probably do is this. Let's see. No, this doesn't work either. Oh boy. Of course, I could always add the whole thing and subtract what I want, but I'm not sure it's what I actually do want. Let's see. Yes, no. This doesn't look good. Again, now I'm searching for the let's see what this thing does. Okay. R is obviously so. Obviously something goes wrong here, and part of that is obviously the fault. The fact I don't understand what is obviously the fault of the fact that I don't understand how this function really works, because it does really advanced OpenScad magic, I think. Okay. Let's go back here and again, Google, or better said, DuckDuckGo is your friend. Nope. So okay, there is a thing called partial in OpenScad. Let's see how that works. No, it's not a built-in thing, it's a separate function, but here I can at least understand how it works. So basically what it does, it selects a sublist from a list. So now I can basically I can use the add function, which we know works. I cannot explain it to you why. I have to dig deeper into that, and which honestly, right now, if it works, I don't care. Let's copy shit from the internet. Let's add where we got that part. Credit where credit's due, right? So we got it from there, and this one we got from here. For those curious, I will also paste the link in Twitch, but you can just type it from the recording too. Oh, come on. Honestly, I have to go to the right side and paste it there. Here we go. There I found this partial thing, which is basically it iterates over a sequence and then does a list comprehension, iterates in I with start from end here, and then select simply the element of that list. So, and the start is always 0, and no, let's do it here. So the start is always partial. The start is always 0 and the end is I. Let's see if those I's actually collide. I would not think so, but then again, I don't know nothing about OpenScad, right? Let's have a look if that works. Rotations. It goes through. It produces a known variable rotations. Here we go. That was the issue. Here we are. So this looks really good, if you ask me. As always, this last part, as I said, I want the last element to be to click into the heptagonal symmetry. So there I will probably do a modulo operator. Let's see if we have that available and how it looks. So it's defined in the mathematical functions, and surprise, it's a %. Let's see here. It's an operator, of course, and it's a %. So for the last element, so here I would, so what I would do here, if, let's put it that way, rotation, so twist equals twists and then the ith element. There we go. Rotations equals the rotation equals the rotations ith element. Yeah, so for the last element in the list, we do have a issue also for the first element. I yeah, also for the first element, we don't want to have a starting rotation because we want it to start by 0. So the really brute force method is to do it that way. If I equals 0, I'm not even sure I'm doing that right. Let's have a look. Let's go here. And if statements. I've never used if statements before, believe it or not. Not in here at least. So of course it's equals then this one, the rotation equals 0, and there's also an else. There's also else if I equals 9, then we need to do some more magic. And else if all those statements go bonkers, rotation equals rotations I. Why is that? Because in the end, I will, especially for that case, I will need to calculate what my final, first of all, what will my final rotation be? So what I actually need to do is do that with a 360 divided by 7, which is a not so nice number, but I think our precision here is more than sufficient. So now I know what the modulo of actually I don't need the module. Do I? No, right. I need the module of that, and after that I need a I need to actually get that, let's say, let me see something. Okay. I also need to figure out how to typecast stuff in here. Let's not go down that road right now. So yeah, and furthermore, I need to figure. I basically wanted to click to the next. I wanted to click to the next rotation. So let's see. I'm doing some calculations off screen right now. Yes. So actually, I would need to do that. I actually need the divisor of the whole thing. So this should be my... No, this should be actually my final rotation. So this should be my end state. So the twist should be the rotation is fine. You know what? This is going to be really bonkers. So I don't want to break my head over this yet, as I said, because I don't want to I don't want to occupy myself with that, because there are other issues that I need to fix first. So now theoretically we have the rotation, and we have the offset anyway, and we have the twists, and the rest, the height, the slices, the scale is not yet something I want to worry about, because I also would like to have it dynamically scale. I don't want to worry about that yet. Let's put it that way. So let's go and see how that works. Section. So Z offset equals Z offset. Twist equals twists, and equals twist, and rotation equals rotation. This is gonna go horribly wrong, and yes, as I said. I don't need a semicolon there, I need a comma, because those are arguments to a function. And yes, this whole thing went bonkers. As you might be able to see. Why? Because I forgot that this goes the other way around. Did I though? There are errors. Let's put it that way. You see here there are 20 warnings, and those warnings persist problem converting rotate. So this rotation here for some reason is undefined in 20 cases? How's that even possible? So let's just return the rotations and have a look. So for some reason it seems to think that the rotation is undefined, and there are two oh 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 all right. I didn't know that. Thank you very much. Melmoth told me that variables assigned assigned inside the if blocks are not visible outside. So how do I do that? Of course, I could do it that way, which is ugly as hell, but would work. Yes, of course. Yes, that would be, of course, possible. So basically, what I suppose I don't know yet how, but what Melmoth suggested was to have this thing in a function that goes like this. Boom, 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 boom. Function calculate rotation, or I prefer get rotation I, that actually returns that would actually return the yeah, I see you. I see you. So this is really, really, really annoying. What I of course could do is define a module up here again that is basically just calling that with only the rotation as a parameter. Let's call it that way, and have the rotation here, which then again calls a which calls the module section with rotation equals rotation. Then twist equals twist, because I can access that variable from there, at least it should be, and z offset equals z offset. And let's see if that works. Blah blah. So now I just can call the subsection with rotation like that. I can call the subsection with rotation equals this, and here again I can call this subsection with this. So let's see if that breaks or not. I still have 20 warnings Why is that? Ah, of course. That is why. Why are you complaining there? I do like how the syntax errors don't really tell you what's wrong. It just tells you that there is a syntax error. Ah. Melmoth, do you have an idea where that goes wrong? What could go wrong there? Because as far as I see it, this should work. Oh, can I not access this twist? Because I should be able to. Anyway, let's try this. Let's try it. I will try it that way. I think I cannot access the variables from above. I don't want to call the above because that would have massive code duplication. But yeah, then again, I simply could just. I want to shave off lines of code if you get me there. Let's see. That should work. Nah, okay. Let's call the real thing. Rotation Z offset equals Z offset and twist equals twist. And let me copy that. No. Let me copy that part, paste it there, and paste it there. And remove this part. And this should work. And of course it doesn't, because I screwed up the part with the rotation, because again, it's negative. So something's not right yet. This is close, but not yet there. Why is that? I think I have the wrong rotation for the wrong. Let's try this. No, that's horribly wrong. It doesn't quite align. Sometimes it does, sometimes it doesn't. And this, no, it doesn't at all. It's off always. But the question is by how much? I mean, okay, the first element should be, let's try this. Oh, this goes even horribly wronger. Yeah, that's what I thought. That's why I tried to have the -1 there, which doesn't do jack. 0, if I don't offset anything, then nothing happens. And if I do this, then I have no idea what's happening. Oh, yeah, but I do need the twist to be of. It is still. I have a quite Melmoth really is helping me out here. Shout out to him or her. Definitely helping a lot. So the discussion is, it's still Melmoth says it is still added at its end as its end twists 0. Yes, that is true, but the 0th element should be twisted by the amount that is that the twist is in 0. So this twist actually corresponds to the 0th element, to the correct element. This is perfectly fine. The thing is, the first element should have the value that is in twist 0. So let's just do this. Of course, this doesn't work that way. Let's just do this and figure out what's wrong. So let's return echo rotations. Let's return rotations and twists. No, I prefer it the other way around. Due to the causality relation between the two. Let's see. So the first, okay, this should be -1 in theory. Now, of course, this goes negative. And there we have it. You're right, it was an offset. I did try the offset, but I didn't add negating the offset. Because again, the one goes counterclockwise and the other goes clockwise. Go figure. The twist goes clockwise, the rotation goes counterclockwise. Again, go figure. So this should work better now. Let's have a look. Yay. Except for the last element. This goes bonkers. Surprise. Because this, again, does not do what I want. So, what issues are we facing for the last element? I want the end position to be... I want the end position to be in the place where the... I want the end heptagon to be where the starting heptagon was initially. Not initially. I want to click to the next possible. So basically, the issue that I have here is that my rotation so the question is, do I want it to rotate it maximally to the next position, or do I want it to click to the one before? So do I want it to go from 0 to 1/7 of 360, or do I want it to go from 1/7 of 360 to 2/7 of 360? I think I want to do the first one. I want the rotation to be maximum, to be the least, to be the remainder, to not be the modulo, not be the remainder, but be the multiply, what I need to do to multiply it. Let's see if I can typecast variables, because then it's fairly easy, I do think. Famous last words. Typecast. So, okay, wrong. The rotation is not the issue. Is how much do I want to twist it in order to fix the rotation, in order to get it to the end position. So how much does the twist need to be? And for that, okay, there is actually a typecast. And for that, I might need, let's see if that works. Yeah. So, let's see. Oh no, not what I wanted actually. Let's see from here. What third? Yeah, we probably need to go. Need to take a. Need to figure out. We probably need to work something out here. So. Okay. So, how this would go is we would have the twist should be equal to the rotation minus the rotation modulo 360 divided by 7. I'm not sure. I'm not sure that this is the solution that we should go with. Melmoth proposed something like rotation 9, so the last element of rotation. From that, subtracted the twist 0 plus 30 modulo 30. I'm not sure what the 30 is supposed to be, because actually the angle of symmetry is 51.4285 and something something something. So this this actually should go really, really bonkers, because I reassign a variable, but let's see how that goes. And I don't want 0.7, I want it divided by 7. So this actually gives me the previous rotation of the whole ordeal. So this this gives me the previous this gives me the last step that the rotation did, and to that I need to, of course I can do it. No, I cannot really do that. And to that I need to add 360 divided by 7. And let's see how bonkers this whole thing goes. Yeah, we do have little to no rotation here, as you might be able to see. Let's go twice the amount. How that goes. Yeah, of course, it clicks to the next one, right? So, yeah, of course. No, this again needs to be. This gives me the point where it clicks. So now what I would need is, let's try another seed, but because I don't like the last part. It goes always like this. I wonder why. Why the last step goes vertically. Oh yeah, of course. No, what? Yeah, of course, because I am a total idiot. And this is much better. Yeah, that's more or less what I expected. That's what I was thinking would happen, because we are rotating it now too much. We are rotating it by the amount that the previous one is rotated in relation to the next step. By the amount the last element is rotated. So this whole thing needs to be divided again by the what am I doing here? I'm really going bonkers. Okay. So I want the amount the last rotation deviates from the next step, which is basically this. Yes. Is it though? Nope. 360 oh, come on. Divided by 7. Ah, now this looks good. And let's go and do some iterations. Let's see how everything looks. Yeah, what's wrong now? Ah, of course, the seed is bonkers. As far as I can tell, this looks fine. What would you say? I'm happy with that. I'm really happy with that. Like really, really, really happy with that. So, okay. This looks really good. Um, yeah. This looks really, really nice. Um, okay. Now let's see what we can do further. Furthermore, I would like to have some scaling. Which means that we need a further. So I want to vary the diameter. Again, I want the last diameter to be. Again, I want the last diameter to be the same as the first one, which is let's go radii. No, scalings. So I want the last, the first one, the last diameter to be the same, which means that the first one will be the default. Let's go with 60. And again for the for the last one, we need to do a bit more work. And here also we need to do a little bit more work because we need to calculate what the initial radius of the first object needs to be. Also, I don't want the scaling to be from 0 to 30. I want the scaling to be from 0.6 to 1.4. I even think that might be too much. Okay. So, the radius. Oh boy. This whole thing is, of course, again, a function of this whole thing is, again, because they are multiplications, we need to do something like the add thing, but with multiply. Let's see. if that works. I'm not sure, to be honest. Okay. What is actually the inverse value of 1.6? 1 over 0.6. What's that? It's 1.6. Surprise. Let's be more precise, right? Or let's pick something that's better. Let's go with 7.5. Of course, that's wrong. Yeah, I don't want to deviate too much from the thing, and I don't think it's gonna explode too much, right? Let's see, what's 0.8? Ah, that's nice. Let's do this. This is those are numbers I like. So again, let's put the scalings, because these are angles, these are scalings. And let's see if we can get that for the radii. For I equals 0 to 9, we multiply partial scalings 0 I and a semicolon to make it nice. Let's see, and let's forget it. Echo radii. Let's put it that way. We didn't do anything here. Let's see. It doesn't like me. Oh, of course. You see what we did here. Rand_s I think only produces integers, so we have to go back and figure out what the No, actually it doesn't. No, it does not. It does not. It does not produce only integers, because if we go here, if I recall, those are perfectly fine float numbers. Oh yeah, yes, of course, you're perfectly right. 0 is the yes, thank you very much again. Melmoth saved the day. I completely screwed that part. It looks good. I do like the scaling here. It looks pretty decent. So here, of course, the radius is 60. Here, the Is it though? I think I need to do that to get the final radii for the whole chain, and I don't know why you don't like that. It says there is a syntax error. Oh, yeah, of course. Yeah, those radii look good, if you ask me. So we need to have for this, the scale is scalings I. That's the scale. That's the final part. And radius. Did I call it radius? Yes, I did call it radius. Surprise. Is radii I minus 1. And I don't expect this to be correct. So yeah, Melmoth afterwards or now, if you apparently somehow we've met before or something like that, I would be really, really glad if you could tell me who you are, so I can poke your brain, or we can maybe collaborate in the future or something like that. If you are up to it. If you don't want to, it's perfectly fine. I'm happy with that. I just see that you can teach me a lot. Thank you very much for that. A big shout out to Melmoth _the_ sheep. So I need to check my phone for something. Okay, nothing too big. So this is gonna go. My expectation, this is gonna go everywhere except the direction I want to, but yes, pretty much what I expected. This thing exploded for some particular reason, which is not good. I don't want it to go that overboard, so I would actually need to. I want this to be less. I don't want to get it to, and also this. Let's see. .9 and 1.1. Let's have a look at that. This looks much tamer. Although here I do need to add the scale, which is scalings. If I use the correct brackets, it works better. At least I've been told so. Yeah, that looks much better. So yeah, those fit together. Again, the only thing that does not is, of course, this part here. So let's go there and indent those two. Because here we would need to do a bit more bit better mathematics. So again, what I need to do is take the final radius, the pre-final radius, and reduce it to the final one. So this would mean that my scale, I do know the radius I want to go to and the radius before that. So I just need to figure out what number do I need to multiply by the previous radius in order to get 60 in the end. So what do? I get the radius, the previous one, that part. And if I divide 60 by that, I should get the scale I want. Let's see if my middle school mathematics taught me well. So scale equals scale. So, no, I did something very horribly wrong. Yes, I forgot a semicolon. Nobody who ever programmed had, of course. Bloody hell. I need to do it the other way around. Do I though? No, I don't. Oh, no, I do, because also I need to set the radius. And the radius is here. Radius equals radii I minus 1. And a comma there for beauty's measure. I'm not even sure that fits well. This could actually work, but I'm not sure. So now we have this whole thing. First of all, we have the module. We have defined some functions that are useful to us. We have defined some random twists and cracks here, and some random twists and scalings, and we also have defined a for loop here. And this whole thing here, I think I would like to have in a separate module and call that Heptastack. Always remember to indent in the right direction, kids. Alright, so we do have our heptastack. Now nothing should happen if I render this. Yes, of course, because I haven't called it yet. Heptastack. And this should work. Now, if the first one and the last one fit together, we will find out by translating the heptastack, not the verb, the adjective, by 250 in the z direction, and add the heptastack there. Let's see, does that where the end is. Yep, this looks good. If you ask me, this looks very, very good. Now, what I actually want to do, I want this to be a hull. I did mention it yesterday. There is a function in OpenScad that is called hull. Let's see how that goes and how that works. No, I don't think it does what I wanted to do. Basically, I also said it yesterday. It's not that hard. We just have to shrink down the whole thing in the Y and X direction. So difference. Let's first define a unique heptastack. And let's go there. And A, and then scale, semicolon, don't forget the semicolons, kids. 0.95, 0.95, and 1. And the Z, I don't want to shrink it vertically. I just want to shrink it in the Y and X direction. So this should produce a very interesting shape indeed. Why is that? Let's put a union there. Yeah, nice. Boom, 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 boom. Let's put a union there. This kind of looks better, I think. Yeah, this thing will take various interesting shapes. Yeah, so and then a cube by this dimension, a centered cube. It always bugs me that it's not. I cannot write it properly. That is CENTRE, but whatever. Times 0.1 and another cube, also centered. But this time translated by 250 millimeters up. And let's see how. Really? Really? Why? Why is that? This is really interesting. I do hope it's a rendering issue. Cause I don't know. But yeah. This. Whatever. Okay, let's do that. Is it though? Because here, I think you're right. Yes. So basically, I should fix the seed. I should calculate the seed first and make it a variable here, so that it's always the same version. Am I correct, Mammoth? I'm not sure. Also, what I'm not sure about is those interfaces here, those boundary layers. I thought that with a union I would get rid of them. But yeah, sure. Yeah, that's what I meant. That's what I meant with to have seed as a single random number. That's what I meant with having it as a variable. So twist and seed equals seed, and scalings seed equals seed. And now I will need to generate a random seed here. No, if I generate it there, everything would go haywire. And of course I need to define it, and a good value for seed is always 23 or 42. This is always the best value there is. And here I will calculate, and seed equals rand s 0 to, I don't know, whatever, 0 to 42, 0 to 42, and I want one number, please. And from there I take the first element. Let's see if that works, right? Oh, much better. Oh, yeah. They are, of course, far too small. Those cubes really don't make a difference, because they, what I do with those cubes, I really slice a really thin layer on the top and a really thin layer at the top, at the bottom. We're talking about 0.05 millimeters, which is way below the tolerances of a off the shelf 3D printer in a standard configuration. I mean, if you optimize it, then obviously you can get lower resolutions, but most 3D printers nowadays have variations in that order of magnitude. So I'm not still I'm not sure about the boundary layers. Still, I'm not very sure about the boundary layers, to be honest. Let's render this, and let's export it as an STL, and let's see what Cura does of it. Now we wait while my laptop heats my room because it's cold or something. You see, I'm wearing short sleeves, so it's very cold. Let's have a look at the load. This is going to be interesting. Yeah, it's basically heating the room. And I'm not really sure why. I mean, okay, OBS is of course a major load generator, but I'm not sure why it takes long to render the 3D model. Oh, okay. This of course takes forever to render. Ah, you don't see it. This should be it actually. You see this blue bar here? This says I'm not done rendering yet. When it's done rendering, we will get notified. It will make a funny noise you won't hear because my audio from my computer is muted towards you guys. Oh, you people. I have to get rid of that, guys, sooner or later. Now for some PSAs, please wash your hands, stay the fuck at home, and wear a mask if you have one, if it's possible for you. And if you need people, there are always people around. Ask this people on the internet. They are also bored at home. Also, if you haven't heard from friends in a long while, make sure to give them a call. It probably make a difference. So we are done now. Let's start up Cura and have a look what it does with that. Ultimaker Cura is loading. This is also a resource fryer, to be honest. This thing loves to fry resources. There we are. First of all, of course, I need to export it as an STL. Let's go up, there, up, create a new folder, Twitch 2020 0418, and save it here. Random heptagons. I would call this, no, I would call this heptagens. I love it that way. So, and this, let's save this also under that. Nope. Here. Heptagens. Ascat. Save. So, let's go here. Open the file. Yeah, of course, it's too high. 250 millimeters is too high. Not to worry. We can go down in that direction. Let's go to, I don't know, let's go to 70%. Okay, 70% was too much. Whatever. Now I need you. Oh, so let's bring the height down to 80%. This is still a bit too much. So this fits. Let's do a test slicing and see how this works. This, of course, is best served with semi-transparent filament, so semi-permeable filament, such that you can actually light it from the inside. And what I would also like to do, have a small camera and pull it through the tube and have like a real 3D tunnel effect that we would have, that is very famous in the demo scene. Yeah. Let's have a look. Cue the Jeopardy melody here. In general, I should add that as an effect. And now let's have a preview. What this thing looks like in layers. Or how people would say, it's layers all the way down. Many, many, many layers. And you can see... No, that's not what I want. Bloody hell. Now I need to slice it again. Yes. So yeah, I would be. I'm totally looking forward to see the first prints with that. The code itself will again go up on GitHub. As I mentioned already, as I already mentioned yesterday, and I still have to upload it. Yesterday's code is merely a click thingy, and it's not really done yet, right? I mean, if you want, you can submit patch. I will do it. I will do it tonight probably, and we'll make announcement on my Twitter and Mastodon. See the links below. Somewhere here in this thingy here, there should be links to my social. I added them. I don't know how you can read them and how you can see them, but yeah, please feel free to contact me if you need anything, if you have ideas, if you want to meet up for a beer or something. And here I think actually I need to make the shell thinner and this needs to be printed with 100% infill. How do I do that? Let's go here. Oh, infill density 0. What the actual? Okay, let's go slice again, because my CPU is bored to death with OPS and with OBS and everything. We have a load of 8 on a 4-core CPU on a 4-core machine, of which 2 with 2 physical cores. So yes, yeah, I know. Multi-threading and stuff like that, but sorry, I need the cores. I need them. So, and after this is sliced, I will probably end the stream. But there's still time for that. Let's have a look how the whole thing turned out. And of course, the following days, probably on Monday, because tomorrow is Easter for me. I'm Greek Orthodox, so I am Greek Orthodox. Like, yeah, you understand what I mean. It's a cultural thing where I'm from. So tomorrow is a big day. We're planning to do some big eating. Oh, it only needs 4 days and 2 hours and 43 minutes to print. I think I will need to scale it down a tiny sliver. But yes, so yeah, tomorrow there will not be a stream. There will be a stream on Monday, probably again. Probably like yesterday around 2 o'clock in the afternoon, 2 o'clock Central European Summertime. That's 12 o'clock. UTC. So please adjust to your time zone. And yeah, so that's gonna be the next stream, probably. Oh, doesn't look too bad, does it? I will definitely make the shell thinner. I think this is too much. I mean, we can think about it. It's 60. Let's estimate. Okay, so this thing is 60 millimeters in radius, and we shrink it down by 95%. Let me see. We shrink it down by 5%. So we have 5% of 60 millimeters, and this is 0.5 times 60. Those are 3 millimeters wall thickness, and I think that's too much, to be honest. I think I'd rather go to 2 millimeters. I think 1.5 millimeters is more than sufficient, given that it shouldn't have structural load on it, except vertically. And this should be at 97.5%. Of course, I could have done that in my I could have done that in my mind, but yeah. Why think when you can be lazy? So let's again do the render thingy. So yeah, that's it for now. If you have any ideas, please feel free to contact me as you please. And I would love to hear from you. If you would like to print it, again, I think that tonight sometime I will push it on my GitHub. GitHub is again Madonius, like it's used to be. Yeah, like everywhere you can find me under that name. Okay, thank you very much, and stay safe and stay healthy. Bye bye.